So let me start with the demo session as of now. And first, I want to introduce about Hadoop here. And let me go with some history of Hadoop and why Hadoop and all those stuff. So you'll be getting a good glance of Hadoop. Let me start with Hadoop. Okay. So in market nowadays we are hearing about big data, right? What is big data? Okay, then now let's talk about data first. What is data? Data is nothing but an information, right? It's nothing but an information. Whatever the thing we are going to store in our PC or laptop or mobile or tab or whatever, wherever the data we are storing is. Whatever the thing we are storing in an electrical machine or the computer, that is nothing but data, right? If I am going to write my name, that is nothing but data. If I am going to enter my details somewhere, that is nothing but data. We are storing it, right? So previously, the usage of computers are less. Yes, right? The machine usage is less. But nowadays, from past 2 to 3 years, it has become more. Like it was increasing a lot, right? So obviously the data will be increasing. For what we are using computers? For storing of data, right? So obviously the data will be increasing. So huge amount of data is nothing but big data. That is what here I am going to present you about big data, right? Of course, huge amount of data, but let us see who are going to produce huge amount of data, right? See, as far as we know, Google is the best search engine. So there, whenever we are going to hit it, it produces back the data, right? So as you can see here, Google can produce 20 petabytes of data per day. Okay, just a second. Yeah, see this. Google can produce 20 bytes of petabyte per day. Then just remember, like petabytes of data, right? See, what will be our machine's configuration? It will be like 100 GB or 1 TB max. Nowadays it's 1 TB max, and it's not more than that, right? So if you are going to have some huge amount of data, over there, like if you have some 2 TB of data, can you put that 2 TB of data in your machine? Of course we can do that by adding some external device. That's fine. But if it is more than that, if it is more than 2 TB, if it is 20 petabytes of data, then what's okay? I think you know this, right? Like 1 petabyte is equal to 1024 terabytes of data, right? So if it is that huge amount of data, of course they have some databases to store the particular data, but retrieving of the database is not that easy. Okay, and as you can see here, the similar example like Facebook, it produces 2.5 petabytes of data, of user data. It's not the whole data of it, it's just the user data, and the whole data of Facebook will be of 15 terabytes per day. Okay, that's nothing but it's increasing a lot. Just like it's growing more and more. As the same, we have some shopping websites, right? Like not only in abroad countries like US or Canada or something else, but even in India, it's increasing, right?
Yeah.
As you can see, there are many shopping websites nowadays, and they are increasing a lot, and even they are successful, right? How are they successful with that huge amount of shopping carts? As you can see, some famous sites like Flipkart, Snapdeal or Myntra or something else. They consist of some thousands of products, right? They consist of some thousands and thousands of products which have some many distributors or dealers or something else, right? So how they can exactly verify like who places this order and for whom I have to send this order, all those things. These are all because of software, right? That's all because of software. If they have some less amount of data, they have many databases like Oracle, DB2, SQL, and something more. They have many types of databases, right? And also they have many tools here to retrieve back the data. That's fine. But nowadays, as per scientific studies, I said that previously we have some 1.8 petabytes of data more than 10 years back. But from last 2 years, it has been increased to from before 2 years, it was 18 petabytes of data, and now, as you can see, only Google is producing 20 petabytes of data per day. As you can see, the data is increasing lots and lots. Okay? Like the scientific studies also proves that for every 1 year, whatever the amount of data we have now, as of now, suppose if we have some 1 GB of data today, for next year it will be 2 GB. That's nothing but the twice of data will be done every year. Right? So to handle those huge amount of data, what we should do? We should have some strong database.
Yeah.
As well, we should have some strong tools to process it, right?
Yeah.
These are the amount of data, and let me explain you the type of data. Like here we call 3 V's of big data, and as you can see here, three colors, right? Like volume, variety, and velocity. This is the type of data. See, producing data, storing data, retrieving the data, it's a part. But what is the type of data? You should see that mainly, right? What is the type of data, and what is the structure of that? Like, is it a structured format or it is an unstructured format? Also, you have to check it, right? So, because if you're going to opt some database like Oracle, example as Oracle, okay? Now the present database is Oracle 12c in market, the latest one. It can store data only in a tabular format. As you can know, like it can store table only in a tabular format. Big thing. But if you want to store some text file, can you do that? Like if you have some paragraph just as this, like whatever you have seen, can you store this in some database? No. It's an unstructured data, so you can't do that, right? But if it is a database, like if you want to store anything, like whatever the data it is producing, then it should definitely support the structured as well as unstructured data, right? As I'm saying unstructured, what is the unstructured data? Like text files, whatever I said now as an example, and also the censored data. Nowadays everywhere it's a sensor, right? As you can see this.
Yeah.
It's a sensor, right? Like whatever the doors opening or fans, lights or anything. The sensors are increasing more. How does sensors work? Through some data, right? And audio files, video files, some log files, all this stuff can't be stored in databases, and the processing on those things are not that easy. Of course, we can do that, but it's not that easy. See, suppose if you are going to purchase something, like if you are going to purchase some brush for use, right? So, what are the things you want to purchase? Like a shirt, a pant, like our jeans, or some shoes, or some goggles, right? So, if there is a shop only selling shirt, and if there is a shop only selling jeans, and if there is a shop only selling shoes, and also there is a shop which sells all the things, then which shop do you have?
All the things.
The final one, right?
Yeah.
All the things, right? Because you don't get wastage of time, as well you will find everything at one place. So now also even we have many tools, but why we opt some big data tool like Hadoop is nothing but it can show you everything. It's just like one stop. It has everything over there, like structured data you can format, unstructured data you can format, and it can store it and retrieve that easily. Like see, if you are opting some database like Oracle 11g, it can only store the data. Will it retrieve the data itself? No, we have to use some SQL Plus or SQL developer to do that, right? But here we have some ecosystem of Hadoop of own itself, its own ecosystems. So it's a one-stop destiny, right? It can do anything itself. There is no need of outer tools to come in and work on it. That's a major thing. Then that is all about variety, and about volume already we have discussed, right? A huge amount of data. Like whatever the individuals or organizations are producing more and more of data. That's nothing but big data. And the final one here is nothing but velocity. What about velocity? Even data has some velocity, right? Like the generation of data and capture of data. Like how we can say is simply the production of data at some particular point of time. Like suppose if this particular point of time, some 10 users are registering in some website like Gmail or something. So that is nothing but parallelly it should work on database, right? Like all the 10 users should work at a time. Like at the same time they should get the response, right?
Okay.
So that is related to velocity. Even this velocity factor will be some point of disturbance. Sorry. Even this velocity factor will be some point of disturbance for normal databases tools. They can't work that easily. But as far as Hadoop, it can work easily. Okay. And why Hadoop? I said, okay, database and all those stuff are clear, right? But why Hadoop? Hadoop is a tool developed, like it's a framework. You can't say even as a tool, it's like a framework, okay? It's Hadoop is a framework developed for big data. Okay, how Hadoop came into existence? Let me give some history of an Hadoop like this. Like first Hadoop was introduced at Google. We can't say that as Hadoop, but the name of that project was Apache Nudge. Okay, first Google released a white paper called MapReduce. Okay, in 2004, around 2004, they released a white paper called MapReduce by Doc Hutting. He was working at Google at the time. Doc Hutting is the author of Apache Nudge. I mean, he is one of the partner, a team member of Apache Nudge project and author of Hadoop, of course. He was at Google in 2004 and they released a white paper called MapReduce. Right? By inspiring with that white paper, we want to extend that Apache Nudge project to Hadoop. Okay. So he joined Yahoo. This is Yahoo is a company, right? You know that.
Yeah.
In 2006, he joined Yahoo and did that. Like he extended Apache Nudge to Hadoop. So first introduction of this was done at Google, but I mean he got all the overview at Yahoo. Of course, the basic thing was introduced at Google, so we can say Google is a point of origin for Hadoop, right? And that project name is nothing but Apache Nudge, as you can see here. That is nothing but the project of Hadoop. And one more thing here is you can see this yellow elephant, right, for Hadoop?
Yeah.
Why that yellow elephant? Like we have seen, of course, we have seen some different names for software. Like for Java is a programming language, you know that, right?
Yeah.
But Java, why it is a Java? There's some history for it. Like the same, we have some history for Hadoop here. Like Doc Hutting has a daughter. She has an yellow elephant as a toy actually.
Okay.
That toy, she kept the name as Hadoop. It's the name of her toy.
Okay.
What happened is while he introduced this project, he wanted to put some name. But what's the thing he thought is, let me put a name which has no meaning and which is not related to technical terms, because he wants all the people to understand the words. Like if you put some technical name, so people may not understand, and if it is not, it's just a nonsense name. He thought like, we'll put a nonsense name, so it will be good to he can create hype for that, right? What is this Hadoop and what is this Hello Elephant?
Yeah.
That's what the history behind this name, and he put the same symbol for it, and he put the Hello Elephant, and the name of Hello Elephant is not Hadoop here. He put the same name. As we can see, whatever the ecosystems, generally we call as tools, right? Tools. Here in Hadoop we call as ecosystems. Okay, the naming conventions differ here. Here the ecosystems are all named as some animal names or something else like that. In Hadoop everything will be related to animal names. Okay, most of it, but not like that. all the things, but most of the things are like animal names. As you can see, next slide you can see that. So this is the history of Hadoop, how it was invented. And yeah, I said like databases and Hadoop, right? Difference between them. So let us have a good glance of that differences. So you will be getting a clear picture why we are opting Hadoop rather than the database which we are already using from past many years and which are successful, right? Of course, the databases are successful, like RDBMS, like Oracle or something else, or already successful databases, right? But why we should opt something else? We have to see these differences, so only then we can understand why we are opting Hadoop instead of some database like RDBMS, right? Hadoop here follows MapReduce computing paradigm. There's nothing but whatever the process inside in Hadoop, it runs according to MapReduce. Right? MapReduce is an concept of Hadoop, and Hadoop entirely works on concept of MapReduce. Okay? Hadoop entirely works on the concept of MapReduce that acts as major role here, as you can see in further classes about that. And let us have some difference between the traditional database and Hadoop. First thing, scalability, like storage. See, as I said you, if the data is more like terabytes of zettabytes of data, the database can't handle that huge amount of data. But Hadoop can do that. See, if you have some 20 petabytes of data now, and if you are going to add some 1000 petabytes of data tomorrow, Hadoop can handle it, but database can't do that, right? And I have mentioned here thousands of machines. What the thousands of machines means? Whatever the database we have, people work in an environment called network, right? Like cluster. We store in a clustered environment data. If you work on some thousands of machines in data through some database, I don't know whether it can handle that number of machines. It may fail. It may take more time, but as of Hadoop, it can handle thousands, not even thousands. If you are going to add some more thousands of machines, even it acts as same as it acts first, right? So it's scalable. So you can add many machines whatever you want. And the next one here is flexible. It's flexible. As already we have seen here, Hadoop can store any type of data, like structured as well as unstructured. The database can store only structured data, right? Here, unstructured data we call in technical terms as schemaless or no schema, right? Without any schema even, the data can be stored in Hadoop, and you can easily process on the particular data. Like you can retrieve out of this. Suppose if you are storing the student's information in a text file, can you do can you get all the students' contacts easily, only the contacts of the students easily by storing it in database? First of all, you can't store that file in database, right? So in Hadoop you can do that, and you can get whatever the data you want by dividing that and like processing that. You can get the data easily. There's a major difference, and that is what companies are opting Hadoop, because whatever the data they get, they can't guarantee that all the data will be in a table format, right? So that's easy for them. And the next point here is efficient and simple fault tolerant mechanism. Whatever. It's efficient. That's fine. We can say anything is efficient, but why? Why it is efficient? Like, suppose if there is a machine failure in some database or wherever the network cluster set up, we should manually go there. We should do some operation over there, and only then it acts, and only then we will get the data. But in Hadoop, it's not like that. Like it has some automatical recovery, right? Because it will store data in a replication factor way. Like replication here is nothing but duplication. Like in normal databases or wherever, generally wherever the important data we have, we will store that, right? Like the backup, we will call it as backup in normal terms, right? Backup will put it. But in databases, if anything fails, that's it. If there is no backup, that's it. Everything is gone. But in Hadoop, it's not like that. Like we have replication factor here. It's something like, if you're going to store a file it automatically stores some 2 copies of that file somewhere in the same cluster. Okay, if one fails also, some other comes into existence and gives us back the data. I mean, no one needs to involve in that, like admin or developer, no one needs to involve in that. It automatically gives us the data. It has the capability and it has the functionality out there to do that. That's the best part of it. And the most interesting thing for company people here is nothing but commodity inexpensive hardware. Like suppose if we are owning a company, like or else some institute or something, if you want to store some data, you should opt some databases, right? As I said, Oracle is a licensed one. You should pay for Oracle, people. If you are going to use the database, you should pay for them, right? But Hadoop is a freeware, like open source. You don't need to pay anywhere. You can get it for free, installed on your machine, installed on your company's machine, do the process, do the work for free, and do that. You should just need hardware parts like computer and whatever the database hard disk or whatever you want. You just need only that hardware things. That's it. No need of purchasing license and no need of purchasing anything for this software, right? So it is open source. That's the best thing, right? And last thing is performance. Performance of Hadoop is too high comparing to any database because whatever the amount of data we have, it takes no time to give us the retrieval, whatever the programmatical data or whatever the query we trigger, we will get it easily, right? Suppose if you are taking a database and opting a tool called Teradata. I think you know that Teradata is a tool which can process on database, like any type of database. It can get data easily, right? So terabytes can handle only some amount of data, like terabytes of data. Suppose if you are exceeding the data and giving some petabytes of data to process, it hangs or crashes or something will be done. Finally, you don't get output. But in Hadoop, you can get it. As far as now, Teradata is the highest tool which can retrieve data easily, but Hadoop is on top of that. So future, I said that future is nothing but data. Wherever we are going now, it's like computers, machines. It's all some mechanical way nowadays. So obviously, data will be increasing, right? And now the latest inventions are nothing but yes, and like human androids, robots, simply called robots, right? For them, where they'll get the data? We should provide some data, right? And one more thing here is nothing but nowadays the latest concept called IoT, the Internet of Things. As you can search for that in Google. Many of the companies are working on that nowadays, like big companies like Cisco, Oracle, and whatever the big companies are there, they are working on those things. That's nothing but that's the latest technology they are going to introduce, and you can call that as platform even. That is nothing but machine-to-machine communication. Whatever the machine, it automatically communicates with other machine. Okay, no need of any human interaction. So how they can communicate? By using some data. So even that produces huge amount of data. And okay, I spoke about Hadoop and what is the use of it and what are the differences of databases and Hadoop, all the stuff, everything is fine. But first let me clearly explain you what is Hadoop. Of course you can see some points here, but rather than those points, I have some more points to add for this, like it's an openware software. It's an openware framework, you can call it easily. It's an open source framework which works for database. You can call it as database layer. It's not a database. First thing, Hadoop is not a database. It can store the data, of course, but on some particular machines, right? And you can process data easily through Hadoop. And whatever the tools we have in Hadoop are nothing but the Hadoop systems we call. And it can store huge amount of data, and it also can handle some hundreds of thousands of nodes of machines, right? Whatever the number of machines may be, you can add easily in Hadoop. Like suppose if you have a cluster setup with 1,000 machines, 1,000 nodes, and suppose if your data is going to increase, or if if you are going to put some other branch or somewhere. So there also, if you want to add some machine to Hadoop, you can add it easily, right? So that's best part in Hadoop. And as you can see, it follows only simple programming model called MapReduce, as said earlier, right? Hadoop is only based on MapReduce, and you can see here map. This is some familiar with all the Java people, like whoever has Java sound, they will be getting familiar with these collections. Collections is a part of Java, right? A major developed on Java. Whatever internally the work going on, it's all Java, right? So it can handle anything. Like Java is a platform independent stuff, right? So it's used all over the world. So Hadoop can be used on any machine which can support Java and do that easily. And it also supports any type of data, as I said previously, like structured and unstructured data. And the major thing here is Hadoop is based on command line interface. Okay, it's not like graphical user interface as we are using in Windows or some other tools. It's majorly on command line interface. It can support the tools like it can support operating systems like Linux, Ubuntu, Red Hat, CentOS. All these are command line interface OSs. So whatever the OS you want, you can opt it and you can install Hadoop on it and do that easily, right? This is all about Hadoop. What is Hadoop? It's not all about Hadoop, of course. This is about Hadoop. And as you can see here, the ecosystem. I said, right? Tools here are nothing but ecosystems. And what are the major and important ecosystems in Hadoop are these. Like, of course, we have some more nowadays introduced in market, but these are the major things you have to know. And if you guys know these things, that's enough. You are expert in Hadoop. Like Hadoop core is the first thing, which consists of HDFS and MapReduce. These are both common of Hadoop core. By using HDFS, you can store the data, and by using MapReduce, you can process on the particular data. With these two things only, you can perform any operation. But we have some other ecosystems called Apache Pig. I said, right, everything will be in the name of animal. It's called Apache Pig. It was initiated by Yahoo itself. And this is mainly for parallel programming. Like if the people who doesn't know or who don't have idea of programming, like whatever the Java or Python or something you are going to use, if you don't have any programming knowledge, even though they can become an Hadoop developer by using Apache Pig. This is a scripting tool to anyone, whatever the background of them, the software people can learn easily the Apache Pig, which is a scripting tool, and do the same process what MapReduce is doing. In MapReduce, we generally use Java. Okay, we can also use some other things, but most of the companies use Java because Java is in this, right? This is the most famous language, and it's in platform independent, which has some good APIs to connect with any tool. So they opt Java here. As the same, the Pig is parallel for MapReduce, and we have some HBase ecosystem, that's Hadoop database, which was introduced by a company called PowerSet. Like they just started it, and some more people gave good add-ons on further. And we have Zookeeper, which was initiated by Yahoo, which coordinates the things. And this is the most important thing, like Hive, the data warehouse concept. As we have many data warehouse concepts like Informatica, ODIs, and I don't remember those names. We have many data warehouse things, right? So Hive is parallel for those data warehouse concepts. Instead of those tools, we can use Hive here, right? For data processing. It is just like SQL. If a person knows SQL, he can easily opt Hive and do the things in Hadoop. And this was first introduced by Facebook. Even now Facebook using Hive, most of the Hive things, and Facebook all depends upon Hadoop. Okay. And we also have some connectors like Flume. Scoop here. Flume is to to get the live streaming data to Hadoop, and Scoop is to connect it some RDBMS, because whatever the company they are going to join Hadoop, previously they already have some data, right? So they want to get that data also to Hadoop, right? So we need a connector. That connector here is nothing but Scoop. Okay, and we have Uzi here to schedule those jobs. Like we can schedule the jobs. We can go in detail in the time session to work with scheduling and stuff. These are all of the ecosystems, the major ecosystems we have in Hadoop. And with this, the person who knows all these things will be expert in Hadoop. Like, he's the best Hadoop developer. If you know 2 or 3 of these also, that's fine. Right? And let me give a little example of Yahoo, which was using Hadoop from past many years, because they introduced most of the Hadoop things, right? So Yahoo uses Hadoop, which has a large cluster setup of 4,000 nodes. As you can see here, it has a cluster setup of 4,000 nodes, and this was the image, whatever the image you are seeing now. This was the image taken, this was the pic taken at Yahoo. This is the setup of Hadoop over there in Yahoo. Okay. And we have several petabytes of data in this particular storage, and Yahoo runs thousands of jobs every month. Like, see, many people use this Yahoo, right? So whomever want to do processing in Yahoo, directly takes this database in which you are. Like, of course, they have some other places even, and this was taken at the major Yahoo company. Okay. This is the setup of Yahoo, and we also have some example. What is the difference between this Hadoop and the normal usage in Yahoo? Okay. Previously, Yahoo has some other things to store data and process data. Like for processing, they mainly use C++ at the time of starting. Before Hadoop, you can call it as you can see here clearly. I have mentioned here like before Hadoop and after Hadoop. Like it's before Hadoop and after Hadoop. Let us discuss a little scenario here. Like this is a scenario. You have your search engine, right? Yahoo even has some search engine. Right here, whatever we are going to type, like here I'm going to type some energy saving. It's showing us some tips, like it shows us, right, before finishing of itself, it shows us like energy saving, like some whatever related to that, it shows us. That is not much search engine, like search assistant, you can call it as. It's called a search assistant. Previously, even Yahoo had some search assistants, which was developed on C++. It took 26 days of time for them to write a program for them, and 2 to 3 weeks of time for deployment of the program. So finally they got it, but it took a lot of time. But whatever the things they done, it works only on some amount of data. Okay, but after Hadoop, it just took 20 minutes of time for them to write a program for this in Python. Yahoo uses Python most. It's not Java. I don't know why. They opt Python most for their programming languages, and Python is a script, and they use it, and it took just 20 minutes to write a program in Python for them, and it just took 2 to 3 days of time to deploy it. And now whatever the search assistance you have in Yahoo is based on Hadoop. Okay, and it's whatever the search assistance, it's all about the 3 years of log data. Whatever the log data they have, out of all those 3 years, whatever the highest number of searches the highest number of search word that will be displaying first according to this, and they just took only 20 steps of mapping used to write this program. That's the best part, right? So it's easy for anyone to do this, right? Like if they need only some amount of time, obviously the companies will opt that, right? And even though it has some advantages like the data it has, it can store it and process on that even the data. This is all about the Hadoop and Hadoop introduction. And what's the thing here is, as I said, right, whatever I explain will be in a real-time scenario like this. I'll be taking an example of real-time scenario and explaining you the things with real-time scenario as well as hands-on. So I'm saying hands-on. And how can I do that? I can do that with my particular machine itself because I already installed Hadoop on my machine, but not directly on my machine. I installed this on VMware. I think you have idea about VMware.
Yes, sir. Yes, sir.
Virtual machine.
Yeah.
Yes, sir. So it's a virtual machine because I said, right, Hadoop will work on Ubuntu, Linux or something, CLS. My machine is a Windows based, so I can't do that in my machine. So I opted Ubuntu here. Of course, we can do it on Linux also. I also have Linux version with me. So, but we prefer Ubuntu for the beginners because it's easy, like interface is easy to do it, right? So I have this Ubuntu here. This is the OS. Of course, you will get the real-time feel if you go for the full screen here. It won't be like VMware. So here I have some terminal. Just a second. Yeah. So here I have some terminal here. So let me show you whether everything is installed here or not. Yes, for Java, I think you guys know this. If you type Java, for the Java, you'll be unable to see all the commands which we can perform in Java, right? As the same in Hadoop, also we'll get it. I get to that Hadoop here. You'll be getting all the things of related to Hadoop. These are the operations you can perform in Hadoop, which shows something like this. And I don't know whether you guys have idea about this command line interface or not. Let me show you a thing like that. ls is the command to list out whatever the folders or whatever the files we have. Okay. So as the same, I'll search whatever the files I have in Hadoop by using a command called Hadoop fs-ls. This is a command like to list out Hadoop files. So these are the files because I was already working on Hadoop like something else or classes. So I have created many things here. As you can see, these are all the folders of Hadoop, and these are all the operations I have performed on Hadoop. And I have many ecosystems installed on my machine like Pig. Of course, the core Hadoop consists of MapReduce and HDFS. So if Hadoop is installed, those workings are already installed. And Pig is one more thing. As you can see here, I entered into the shell potential of it. It was installed on my machine. I also installed Hive on machine. Hive is one more ecosystem. As I said, this will be just similar to SQL. And here, of course, the command will sourcing with SQL. And I have HBase here. I have HBase installed on my machine. Just a second, it takes some time because it's VMware, right? So I didn't give more space for it like that. So HBase is there with me, and I also have MySQL here, like database. Sorry, it's not root, so let me go into root and do that. And also I have some MySQL here, and we have Scoop here installed on the machine, which you can connect, which I can connect with some other databases and get back the data from them. And I have also Easy and Bootkeeper, which I can't show you here. These are just operations what we can perform. And this is the thing. This is a tool or framework of Hadoop where you can perform all the operations of Hadoop, and it will be good for you, right, if the things are real time. Rather than learning the things like even theoretical part, you can get it in Google. You need to attend sessions for that. As you can go for real time scenarios, you can't get it real time guidance there, right? So this is the best thing where I'll be teaching you the theoretical part first, and then later on we'll go for some practical sessions like this. And whatever the doubt you have, I can clear you, and I can assist you anytime, whenever needed, not only until the post time. I can assist you anytime. That is no problem with me. And this is the things all about demo. So my part is completed. And do you have any queries here?
So what are the features of standalone mode?
Okay, of course, I covered those things at the time of installation or the architecture part. Let me show you some clarity about those things. Like here we have Hadoop. We can install Hadoop in three ways, like single node and multi-node and pseudo-node. Okay, I
Yeah.
can give the order something like single node, pseudo-node and multi-node. Okay, so single node cluster setup is nothing but everything is installed in same machine. Whatever I have installed here is nothing but a single node cluster, because whatever the master node here we call as name node, slave node we call it as data node. Whatever we have here is installed in same machine, right? Because I don't have any network here. As we are going for multi-node cluster setup, that's nothing but the real time.
Mm.
That is nothing but we have to pull the machines wherever we are going to work, and one machine will be acting as a node, one machine will be acting as a name node and all the stuff. So that is called the multi-node cluster, and there is a option called pseudo node in the same machine itself. We can install the things like name node, data node on different JVMs, and this is all related to some architectural part.
Okay.
So I can give some good clarity of it at the time of architectural session. And also we have two types of Hadoop here, like Hadoop development part as well as administration
Admin.
part.
Yeah. Yeah.
Admin, right? Hadoop developer and Hadoop admin. So these both parts are entirely different from each other.
Yeah.
Okay, of course the developer should have some good plans of admin, and admin should have some good plans of developer, but it's not like the both are same. Both are different from each other, and also I can cover both of them, like admin as well as developer. In admin part, I can cover you like single node cluster setup, multi-node cluster setup, and everything, whatever the architecture related stuff, I can do that, because I already work on some installations on my company, like multi-node cluster setup on my single node. So there's no problem with me to work with multi-node cluster setup even. So I have a good idea of those admin administration parts even. So as of course I'm a developer of Hadoop, but I have good plans of administration part, even though I'm not a good administrator in Linux or something else, but I'm a good administrator at Hadoop. That I can guarantee you for sure. That's the thing.
Okay, sir.